So good morning. I have I have placed the explanatory notes on that website, so you can collect it from there. There are also several information that is available there also. So we shall be proceeding with the class from where we stopped. But but before that, I want to clarify certain things on the explanatory notes. The first page is just an explanation of the hypergeometric exercise on the student who crammed 8 questions out of 12, and what are his chances of performing well in that exam. So that is the first aspect of the note. It's telling us that small n, the size of the sample, is equal to 6, because that's the number of questions that the professor will take from the pool of questions. From the 12 questions, he will take 6. So small n is 6, while k, the number of questions that the student has memorized, is equal to 8. So when we take note of that, and we will be able to solve any question that emanates from there. Is that clear, please? Make a comment that is clear so that I can proceed. So get the note. If it's not clear, get the note and you see what I'm saying. Get the explanatory note first and compare it with the exercise we have given you for hypergeometric distribution. Hear me? Maybe it's the network. Also, my voice is a bit down. Can you hear me clearly now a bit? Or it's still broken? So let's proceed like this. I hope you are able to get what I'm saying. So as I said, the first page is for the geometric distribution. The second page downwards talks about the multinomial distribution first, then the gamma distribution. Examples on one or two examples on them. We have explained some of all those things before. It's just for you to is to guide you more on it. So we shall be proceeding to the next item on the notes, the general notes that have been given, and we'll be going to the normal distribution now. The normal distribution. Well, the normal distribution is one of the most popular probability distributions, and it is very, very useful in many instances. It is a continuous distribution with a number of properties. It has two parameters: the mean, mu, and the variance, sigma squared. If you cannot hear anything, please make sure you have joined with audio. Join audio. Is there anybody that can hear me right now? Can anyone hear me?
Yes, we can.
Good, good. So let's proceed. We are talking about the normal distribution. As I said, it has only two parameters, mu and sigma squared. Mu represents the mean, while sigma squared, the variance. So the mean is the shape parameter, while the variance is the scale parameter of the normal distribution. It is a continuous distribution, and it has a PDF given by property 1. PDF given by, it is given there in the notes. Subsequently, I will provide explanatory notes on this one. But the PDF is f of s is equal to 1 over square root of 2 pi times sigma, all multiplied by the exponent of minus 1 over 2 sigma squared multiplied by x minus mu, all in bracket, squared. The range of the normal distribution is between minus infinity and plus infinity. That is, it takes values from negative infinity to positive infinity, essentially on the real line. The normal distribution takes values from negative infinity to positive infinity. The parameters, mu can take negative values or positive values. So it lies between, the values that mu can take lie between negative infinity and positive infinity as well. But the variance, sigma squared, it can only take positive values. The variance is always greater than zero. It is always greater than zero. So it takes only positive values from zero to infinity. That is the variance. Now, the normal distribution is very, very useful because of its nature and many probability distributions. As you when you are when we are sampling from all these probability distributions, as the sample size increases and it becomes very large, the tendency is for those distributions to approach the normal distribution. So that is the essence of what we call the central limits theorem, which is briefly described in the notes. Is saying that when you are sampling from a distribution with mean mu and variance sigma squared, and the sample size continue to increase, then the distribution of the mean S bar, the sample mean S bar, will be tending to a normal distribution that is now defined by the Z statistic, the standard normal distribution with mean 0 and variance 1. So that is the essence of the central limits theorem. It's telling us that ultimately, when you are sampling from a large, when you are increasing the sample size, sampling from a population that has a different distribution from the normal, the distribution of the means of that sample means that you are sampling. Let me describe what I mean. Now, you want to sample on maybe the average number of students that queue up at a certain point in time to make use of an ATM. On a certain day, you draw a sample or several samples and compute the mean of it. That is one set. Maybe you do it for 1 month. 1 month. What that means is that the mean, those means that you have been computing each day separately, their distribution will tend to be normal if the sample size, if you are increasing the sample size and it becomes very large. That is the essence of the central limit theorem. So let us look at some of the properties of the normal distribution. The first property is that it is a bell-shaped curve. What this means is that the curve of the normal distribution has a shape like a bell. You know, a bell is
Yeah! Yeah! Kí ló ṣẹlẹ̀?
somebody is disturbing our class.
Ah! Ó sì pariwo yéé! Ọlọ́gbìn lọ́wọ́ yìí o. Fídíò ọ̀gá sì ṣàlùrò gé ọ̀dọ̀ ọ̀gá ló ti wá ní. Wàhálà. Wàhálà dé. Who screamed?
Well, let us continue. So as I was saying, the normal distribution has a bell shape. That's the first property. And what that means is that it's a symmetric distribution. If you divide it into two parts, one part is the left part is a mirror image of the other part. So it has a symmetric distribution, evenly distributed values between the middle where you divide it into two parts. Of course, the implication of that is that the mean, the median, and the mode of the normal distribution, they are all the same. The mean is equal to the median and is equal to the mode of the normal distribution. They are all equal to the same value. Also, the curve is symmetric about the mean. So the mean is the central point of the normal distribution curve, as well as the median and the mode, because we have said that they are. So the midpoint of the curve, that is the midpoint, and it makes it to be symmetric. Of course, it's a continuous distribution and the curve is also continuous. There are no breakages or discontinuities with the normal distribution curve. Then number 5 is that the curve never touches the x-axis. It does not touch the x-axis. It may approach it, but it will never touch the x-axis. The total area under the curve is equal to 1. That is the 6th item there. While the number 7 one is that the mean is equal to mu and the variance is equal to sigma square. So the parameters of the normal distribution are the mean and the variance respectively, mu and sigma squared. Now, number 8 item on the note is telling us the nature of the normal distribution curve and probabilities that could be computed around the standard deviation. Now, if the variance is sigma square, what is the standard deviation of the normal distribution? Put it in your comments. If the variance is sigma square, what is the standard deviation of the normal distribution? Yes, not stigma, or it is sigma. Sigma, there's no T there. Yes, sigma. Sigma. So the variance is, the standard deviation is just the square root of the variance, and it is sigma. Now we can compute probabilities around the variance. So if you have a centralized variable, x minus mu, that is, you subtract the mean from the variable, from the random variable x, then the probability that that value will fall between negative and positive single variance, a single standard deviation, one standard deviation. That is the first item there. That is probability that minus sigma less than x minus mu, which is also less than sigma, is equal to 0.68. What this means is that there is a 68% chance that when you sample between one standard deviation, having subtracted the mean from the variable, then you have a probability or a chance of obtaining that value. The probability of obtaining that value is a value that is within that range is 0.68 or 68% chance. Now, the next one is two standard deviations. If you are sampling within two standard deviations in the negative side and in the positive side, of the centralized value of that variable, having subtracted the mean from it. That is probability that minus 2 sigma less than x minus mu less than 2 sigma is equal to 95, 0.95. That is, there's a 95% chance that the value that you will get when sampling between two standard deviations, that the value will fall in that range. You have that probability to be equal to 0.95. And three standard deviation, the third one, if you are sampling within three standard deviation, you have a 0.997 probability of the value falling within it. You can see that where you are where you have a 95 in a if you have a 99.7% confidence interval, then it is most likely that any value that you pick from that distribution will fall within that interval 99.7% of the times. That's the essence of the description on item 8 or property 8 of the um, normal distribution. I want to add a ninth one. Can anybody give me the moment generating function of the normal distribution? The MGF of the normal distribution. What is the MGF of the normal distribution? Moment generating function. Make your comments. Make your comments. Well, the MGF of the normal distribution is exponent to minus mu t exponent to mu t plus sigma square t square over 2. Yes, that is it. Mu t plus sigma square t square over 2. That is from that you'll be able to obtain the mean as mu rather, and the variance as sigma squared. So that is that for the normal distribution. I've talked about the central limit theorem, saying that if you are drawing samples from a distribution with mean mu and variance sigma squared, then as the sample size increases, the distribution of the mean, S bar, will approach the normal distribution such that, and you are sampling with replacements, we take note of that, so that the probabilities remain unchanged. So sampling with replacements, then the distribution of that mean, X bar, will approach the normal distribution. And that transformation Z is equal to S bar minus mu over sigma squared over root n, or sigma over root n, will be normally distributed with mean 0 and variance 1. That transformation Z is equal to X bar minus mu over sigma over root n is what we call standardization. You are standardizing the random variable. Add the mean. from that variable and divide it by is now the mean. Is anybody that expected value of x bar is equal to what? If x is normally distributed with mean mu and variance sigma squared, what is the expected value of x bar? That is the expected value of the sample mean. No, it's not 1. Okay, let me put it this way. If x is distributed as a normal distribution with mean x and variance sigma squared, then expected value of x is equal to what? Expected value of x is equal to what? Expected value of x is equal to what? Expected value of x is equal to mu, the mean. Mu. Expected value of x is equal to mu. That is, so the expected value of x bar. What is the formula for x bar? Is the summation of all the xi's all over divided by n. So when you put expectation into that summation and do all the necessary rearrangements, you will find out that the expected value of x bar is equal to mu, the mean of the distribution. What it's saying is that if a distribution has parameters mu and sigma square, where mu is the mean, then the distribution of the sample mean, that is, you draw a sample from that distribution and take its mean. You calculate its mean by summing all the observations and dividing by the number of observations. It's saying that the distribution will also have the same mean. It will have the same mean as the original distribution, and it will have a variance that will be the original variance divided by n. The original variance divided by n. So that the standard deviation will be sigma over root n. When you take square root of that variance of the mean, you have sigma over root n. And that is what is shown on the Z formula there. Sigma over root n. So standardization helps us to transform a variable using the central limit theorem to transform a variable into a normal distribution that you can now look at the various probabilities using the standard normal distribution tables that are available in various statistical tables. So with the knowledge of standardizing a random variable, we can make probability statements about the distribution on the basis of what we know about the normal distribution, that 68% of the values, they fall within one standard deviation of the mean. They vary around the mean with one standard deviation. 95% of them vary around the mean with two standard deviations. And 99.7% of all these things, they vary around the mean with three standard deviations. So with three standard deviations, you are able to capture majority or almost all the observations that you may have in the data. That is the essence of that number 8 term there. And we have now explained more what we mean by the central limit theorem. Before we proceed to other ones, any question? Any question? You make your comment straight away in your question. Put your question into the comment and I will see it. Okay, let me explain property 8 again. Property 8 is telling us that when you have it's telling us that when you have a normal distribution, that the probability that the value, the central value, that is x minus mu, when you have subtracted the mean from that value, that it will lie between minus and plus one standard deviation is equal to 0.68. That is, there is a 68% chance of that value falling within that range. That is the first item. The probability that the thing lies between one standard deviation of the mean is 0.68. Then the next one is 0.95, two standard deviation. Then the other one, 0.997, three standard deviation. So that's the explanation for it. That is the explanation for that item 8 or property 8 that we have talked about. Any other question? The PDF, I've put it on that website. That's my website. Can we use uniform distribution to illustrate normal distribution? Uniform distribution is different from normal distribution. We will illustrate normal distribution on its own, and uniform is different from it. But the principles you use in any of all those distributions, they remain the same. If you are to compute probabilities, the CDF. Now, what we have done in property 8 is, I hope you can take note that these are CDFs, so they are cumulative distribution functions between a range of values. So if we are talking about values that are different from the standard deviation, then you can also have that kind of relationship that is stated in property 8. And we will now make use of standardization, the z-score as it were, that you use together with your z table to obtain the various probabilities related to any particular range of values that you intend to compute its probability for. So the Z standardization is a critical part that makes it easy to deal with the normal distribution. Ordinarily, for the uniform distribution, the continuous one that we have dealt with, when we want to compute the CDF, we have to do an integral and compute. But for the normal distribution with standardization, we do not need any integration. We just standardize, that is, get the z-score. If you are given a distribution, okay, let's look at this example. it is estimated that in the STA 222 class, the mean score of students in the class is 50% or 50 marks. And the variance is equal to 49. The variance is 49. That is mu is 50, sigma square is 49. Now, if we are told to compute what is the probability of scoring, or rather, if we take a sample of 10 students from the class, sample of 10 students, and obtain their various scores in the exam, in the STA 222 course, that is small n is equal to 10. Small n equal to 10. Then and you obtain a mean score of, say, 40, or let's say 45. A mean score of 45. Then you can obtain the Z score for that mean of 45. You can obtain the Z score by subtracting from the mean. That is, Z score for 45 will be the mean 45 minus the mean of the main distribution 50. That is minus 5 divided by the variance or the standard deviation. If the variance is 49, what will be the standard deviation of that distribution? What will be the value of the standard deviation? Put it in your comment quickly. Yes, the standard deviation will be 7. So you will now the Z score, okay, using the formulas available there, what will be the value of the Z score? I've already computed x minus mu, that is 45 minus 50 is equal to minus 5. You will now divide it with sigma over root n. What will be the value? Let's take n to be 16 so that it will be easy. N is equal to 16. If n is equal to 16, root n will now be equal to what? 4. So sigma will now be 7. Then you divide it by 4. 7 over 4. So minus 5 over 7 over 4 is equal to what? That is 20 minus 20 over 7. What's the value of minus 20 over 7? Minus 20 over 7 is 2 point something. Yes, minus 2 point something. Sigma over square root of n. Sigma over square root of n. That is the denominator. Sigma over square root of n. So the Z score for that corresponding score of 45, mean score of 45 that you obtained, is equal to minus 2.86. That's equal to minus 2.86. So with that minus 2.86, you cannot compare it with the score from, the corresponding Z value. If you have, because which is outside the scope of this course. We are only talking about probability distributions. But we can, with that Z score, we can use it to make hypothesis statements and test the hypothesis whether there is any significant difference between the two scores that you have. Whether minus 2.86 Z score is significantly different from what you should expect when you have mean of 50 and variance of 49. We can find that out easily. But that is outside the scope of the course, so let us leave it. We are only interested in the probability distribution, and the normal distribution has been explained in this regard. So I will provide some further explanations in the explanatory notes I will send for these ones later on. So we can now go to the next distribution, which is the student T distribution. Student T distribution. This is what we call an exact uh, sample distribution. It's a small sample situation where you have a situation where the normal distribution is assumed in sampling, but you do not know the population mean, I mean, rather, the population variance of the normal distribution that by which you can use to compute the Z score. You know, in the Z score, in the Z formula, there is a place for sigma, right? There is a place for sigma. But if you do not know sigma, you may have to estimate it from the sample itself. And if you estimate it from the sample itself, depending on the size of the sample, you may not be able to get a correct result if you go and use the Z, the standard normal distribution, instead of the T distribution, which is appropriate for the scenario that you are talking about, a small sample size, and you are unable or you don't have access to the population variance sigma squared. You don't know the variance is not known. The population variance is not known. So you have to estimate it. So in that case, the T distribution becomes handy. We will make use of the T distribution in such situation. So the basic properties of that T distribution, or basic characteristics that will warrant the use of the T distribution is when n is small, the sample size n is small, and the population variance sigma or the population standard deviation, I mean the population variance sigma squared or the population standard deviation sigma is not known. You will make use of the T distribution. It was developed or created or conceptualized by a researcher by name W.S. Gossett, who was using the pseudonym, the nickname, or alias student in his write-ups. So that's how the name came about, student T distribution. So the T distribution, it has some properties that uh, is comparable with the normal distribution, but it comes from a family of distributions that has what we call number of degrees of freedom, the nu that is there in the formula. You can see the PDF. That symbol that looks like V is called nu, NU, NU is called nu, and it represents the degrees of freedom of the distribution. And what does this degree of freedom mean? Is telling us that it is the number of values or the number of observations that can vary, having removed the parameters that has been estimated. So when we are talking about degrees of freedom, we are talking of the variation in other parameters or other values, with consideration that you must take care that you are estimating a parameter, because it is only the sigma square that we are looking for. So we estimate it from the data. That's why we have to subtract 1. Essentially, the degrees of freedom for the t distribution is n minus 1. When you have a sample of size n, then the degrees of freedom is equal to n minus 1. So it has a number of properties. The PDF has been given there. And f of s is equal to nu plus 1. That is gamma nu plus 1 all over 2. And the formula that is there. The range of the t distribution, as you can see, is between minus infinity and infinity. Between minus infinity and infinity. The second observation there is that the mean of the t distribution is equal to 0, giving us an indication that this looks like really a standard normal distribution, because the standard normal distribution has a mean of 0 as well. But the variance of the standard normal distribution is equal to 1. But the variance of the t distribution is not equal to 1. The variance is equal to nu over nu minus 2. That is the degree of freedom divided by itself when you subtract 2 from it. That is property 4. The variance is given there in property 4. So the mean is equal to 0, and where you have degrees of freedom that is greater than 1. That is for sample sizes n. If nu is greater than 1, then what will be the value of n, the corresponding value of n? Put it in the comments. If nu is greater than 1, then n will be greater than what? Did you get me well? For the t distribution, if the degree of freedom is greater than 1, then the size of the sample will be greater than what? Or what will be the size of n? What will be the value of n corresponding? Not 30. We have already said nu is equal to n minus 1. Nu is equal to n minus 1. So if nu is greater than 1, then n will now be equal to, or n, you just make n the subject of that thing. If nu is greater than 1, that means n minus 1, if you subtract nu into n minus, if you put n minus 1 in place of nu, n minus 1 is greater than 0. Or rather 1. N minus 1 is greater than 1. Therefore, n will be greater than 2 when you take the minus 1 to the other side. N will be greater than 2. That means sample size of 2 and above will enable you to obtain the mean of 0. But we know that sample size of 2 is not acceptable statistically. You have to have sample sizes maybe from 10. Then from the computations, it will be approaching the normal distribution or the standard normal distribution when you have done the necessary transformation. So the median and the mode is equal to 0. Of course, the t distribution is also a symmetric distribution about the mean. The midpoint is 0. and one part is a mirror image of the other part, but it's a bit different from the normal distribution or the standard normal distribution in that it has heavy tails. The T distribution has heavy tails in that the the values tend to be away. They tend to be far away from the mean itself. The values do not cluster so much around the mean as compared to the normal distribution. So that's the nature of it. It has a skewness that is equal to 0 when the degree of freedom is greater than 3. And in other situations, it is undefined. The skewness, that is number 5, is greater than 3. I mean, it's 0 when the degree of freedom is greater than 3. Number 6 item is that the moment generating function of the T distribution is undefined. You can see the PDF there. It contains gamma function both in the numerator and the denominator. So to compute the MGF of the T distribution is quite complicated, and it has been said that it is undefined. But you can easily obtain directly even the mean and the variance of the T distribution. So that transformation X, number 8, the kurtosis rather, number 7, the kurtosis. So skewness and kurtosis are talking about the tail heaviness and how the distribution is peakedness and tail heaviness. Those are the things related to skewness. Skewness is talking about the peak, and kurtosis is talking about the heaviness of the tails of the distribution. So the kurtosis of the student T distribution is given by 6 over degree of freedom minus 4, with the assumption that the degree of freedom is greater than 4. That is, n must be greater than 5 in that situation. N must be greater than 5. Then number 8 item is giving us the T transformation that yields the T distribution with n minus 1 degrees of freedom. When you subtract from the mean, the hypothesized mean, that is, if we assume, let us give an example, that the same example of STA 222 students. If it is assumed that the mean is 50, the mean score is 50, but we don't have any information about the variance, sigma square. That is, we don't know the variance. In the first example, we talk about the variance being 49, but now we are silent about the variance, which means that you have to compute an estimate of the variance from the sample that you have. You now draw a sample of 16 students. That is n is equal to 16. What will be new in that situation? When n is equal to 16, what will be the degrees of freedom? Yes? Correct. When n is equal to 16, the degrees of freedom will be 15. N minus 1 is equal to 15. Now you can now compute probabilities and test hypothesis using that T distribution. Of course, we know that the T distribution has is also available in the statistical tables. So we'll go and check that value that we where we subtract. For example, we got 45 as x. We subtract it from that mean 50. That is minus 5 divided by the variance s squared that you will obtain from the data itself, from the 16 observations of scores of all the students. You will be able to compute the sample variance, which explanation has been given there in item 8. That x squared is equal to summation of xi minus x bar all squared divided by n minus 1. It is divided by n minus 1. So when it's divided by n minus 1, it gives you the unbiased estimate, of the population variance, which you can now use in place of sigma square that you don't know. And you now compare it with the t distribution with n minus 1 degrees of freedom. So that is what has been established there. And you can now use that t test statistic, the t statistics, and compare with the value that you will get from the t table with 15 degrees of freedom, the t statistical table with 15 degrees of freedom. And on that basis, you will arrive at a decision whether to reject the null hypothesis that both the sample came from a population with mean that is equal to 50, or you reject it. That is, you conclude that the evidence from the data show that the sample does not come from that distribution that has been specified. So that's the essence of the t-test. It is very useful because of the heavy tail. It is used in ratio computations or tests of hypothesis relating to ratios. You make use of the t test in that regard. You also use it to compare means. You can use it to compare two means, whether they come from the same distribution. In that case, we will make use of a pooled variance, a variance that is consisting of the variance from the first sample and the variance of the second sample. You pool them together and get a sort of their average, dividing them with the degrees of freedom. In that case, for that situation where you have two samples, you have n1 plus n2 minus 2 degrees of freedom. We are not, that is outside uh, the course. So I'm just stating that we certainly we come across it from time to time. The t-test is used in that direction. You now go to the table itself. Having computed the t value, the t statistic, you now compare it with the corresponding value in the table, together with what you the level of significance of the test, whether alpha is equal to 0.05 or 0.001 or 0.10, corresponding to 5%, 1%, or 10% level of significance. So that is how to go about the t test. Now, as I said before now, the t distribution is a bit different from the normal distribution. It's a bit different because of its heavy tails. So let us look at some of the differences between the t distribution and the standard normal distribution. The first one is that the variance of the variance is greater than 1. The variance is always greater than 1. But in the case of the standard normal distribution, the variance is always equal to what? For the standard normal distribution, the variance is equal to yes. The variance of a standard normal distribution is equal to what? 1. Correct. So for the T distribution, the variance is also. Number 2 item is that it comes from a family of distributions that are based on the degrees of freedom, which is related to the sample size. So that is the second item. It has degrees of freedom. The distribution also changes as the degrees of freedom changes. So when n is equal to 16, see that you compute when n is equal to 10, and it will be different from the one that you compute when n is equal to 20. So they will be different for different values of the degrees of freedom and different values of the sample. It's a normal distribution. So it is approximately normal with mean 0 and variance 1 when the degrees of freedom is very, very large, which we can easily see from property 4 of the T distribution. Property 4 is saying that the variance of x is equal to nu over nu minus 2. What is the limit as nu tends to infinity of that fraction, of that function? What is the limit as nu tends to infinity? The limit as nu tends to infinity of variance of x. Compute it and give me the answer. One. Not 0. It's 1. It can't be 0 now. V over V minus 2. First of all, what do you do if you want to get the limit of that fraction? You divide both the numerator and the denominator by V. When you divide the numerator by V, you have 1. When you divide the denominator by V, you have 1 minus 2 over V. So when V is tending to infinity, when V is becoming large, you will now have 2 over V will be tending to what? If V is becoming very, very large, then 2 over V tends to what value? 0. It will be tending to 0 because you're having 2 over infinity, which is equal to 0. So you have numerator is equal to 1, denominator is equal to 1 minus 0. So you have 1 over 1. So the limit is equal to 1. That is the essence of telling us that the limit as n tends to infinity of the T distribution, that it becomes, we already know that the mean is equal to 0. So it is the variance that will now be changing and approaching 1 as the n becomes very large, which is true. You can even try it. Put V to be 100 and compute the variance. You will see that it's very close to 1. It may not be 1 directly, but it's getting very close to 1. So when it's now very, very large, it will be 1. Exactly. So as I said, the degree of freedom is the number of values that are free to vary after the sample statistic has been computed. What sample statistic are we computing in the case of the t distribution? What is the sample statistics we are computing for a t distribution? Yes. What is the sample statistic we are computing in the case of a t distribution? Yes, anybody? The sample statistics that we are computing in the case of a t distribution. We are computing the variance. Because we don't know the variance, we want to estimate it. The population variance is not known, then you estimate it on the basis of the sample that you have drawn. So it is sigma squared, the variance that you are computing, and it is being estimated by S squared, which is the sample variance. Sigma squared is the population variance, we don't know it. S squared is the sample variance which we can easily compute on the basis of the sample available for us. So S squared is used to estimate the unknown population variance sigma squared. So we are only computing one sample statistic, which is S squared. We are estimating one sample statistic S squared, which we now make use of in the t statistic to obtain the t value that you can now compare with the standard value of it from the statistical table. So the variable of interest or the sample statistic that you are computing, estimating in the t using the t distribution is the variance, is the population variance. You are estimating it from the sample because you don't know it. If you know the population variance, you do not make use of the t distribution. Use the sigma square directly and make use of the z distribution. It is when you do not know or you have no access to sigma square, that's when you now rely on the t distribution when the sample size is not too big, generally less than 30. When the sample size is less than 30, you make use of the t distribution. So that's what we have for the t distribution. I hope this is clear enough. Any question? Questions? What PDF? The PDF on the explanation of this one, no, you are not getting it today. You will get it later. But I've already given the PDF from the previous class, the explanation. Questions quickly before we go to the next item. No questions? What don't you understand? What specifically are you finding difficult to understand? So let's proceed. Now, tomorrow we will not be having the class, but we have slated the test, the online quiz for tomorrow 4 p.m. So from 4 p.m. to 5 p.m. the quiz will take place. All the necessary information you need to access the quiz is on that my website. You go there and get all the necessary information. It shall be consisting of what we have done from the beginning up till gamma distribution. Random variables, moment generating function, uh, binomial distribution, hypergeometric distribution, um, and so on. All those things up to gamma distribution, multinomial distribution, and everything that we have talked so far, not inclusive of this class. Those will be tested. So get yourself ready to do the questions from 4 p.m. to 5 p.m. tomorrow. You do the necessary, you answer the questions quickly and submit before 5. Make sure you submit at most by 5 p.m. so that you will not be logged out. Anybody that is logged out before submitting, it's assumed that that person did not do the quiz. So you have to do that, submit long before the time. I hope that is clear. Somebody is asking what will the quiz look like? Well, there are multiple choice questions there that you will pick the correct answer. It also contains a few questions that you have to do, solve the answer and write it out. There's no filling the blank there. You will answer the question and put your answer in the box provided. Then others, you will be asked certain questions, you will be given various options, and you now pick the correct option in your view. So there are a number of them also that you have to pick it has more than one correct option. The ones that have square boxes, those questions contain you have to pick several correct options, all the correct options really relating to the question for you to get the mark for it. If there are 3 correct options and you pick only 2, then you will not be able to get the mark for that question. So those are the type of questions that will be available. One, you have multiple choice questions wherein you just pick the correct a single correct option among the list of options available. You also have multiple choice questions in which there are several choices that there are several correct choices that you must pick all of them to get the mark. And finally, there are questions that you have to answer and input the correct answer by yourself into the box provided for it. There is no avenue for throwing your work. You do your work, do your computation, and put the answer there. The answer that you put in sort of is an evidence of the amount of work that you have done. So those are the type of questions that are available there. Any other question? Questions. Any question that you have, you ask it right away now. I'm here to answer it. If you know what is good for you, you take every quiz that we do seriously. It's part of the continuous assessment, and it will certainly be part of your scores. Take note that this is not an this the course is a written course. It's not CBT. You are to write an exam on it. So we make use of continuous assessment. We will do several tests, both online and physical one, as well as the main exam itself. So you have to take everything seriously. The attendance that I'm doing, I use the main attendance, the general attendance that I put there that you have to do. This one will be made use of. So take it seriously, please. I have seen that less than 30% of the students that are supposed to be attending this class do not attend. Those of your friends who you know are not attending the class, tell them they have themselves to blame. They have every opportunity to attend the class. The class is supposed to be filled up, but less than 30%, even 20% have been attending our classes. So everything that we do in the class, attendance and quizzes, tests, assessments, tests, they are part of your continuous assessment, and it will be part of your results. So you better take it very seriously. Any comment you have, put it on the chat quickly. You try to submit with keep trying or use other networks as the case may be. You must try to submit by 5 p.m. That is how it will go. You cannot say that the network will be bad by then. The network will not be bad all through. It will give you some leverage and you do it. It's a test that should not take you up to 30 minutes. It's a test that will not take you up to 30 minutes. So keep on trying it until you are able to submit. Any more question? We don't write attendance after every class. Occasionally we do that. MGF is part of the class, of the quiz. MGF will be part of it. Everything up to gamma distribution will be part of the quiz. You have enough time to get ready for the test from now till 4 p.m. tomorrow. Put your phone in order, charge it. After all, you are going to use it for 30 minutes or less. So I think at this juncture, we can now end the class. We will continue from where we stop next week, Wednesday, because the class will not hold this Thursday, tomorrow, because of the test. So from 4 p.m., go to the site and do the test. Have a nice day.